Here I have a couple of examples of a Friedel-Craft alkylation reaction. Let's write it here. Friedel-Craft alkylation. And one problem that we need to be aware of is that the electrophile that you form, that carbocation can rearrange. If it rearranges, then you will have a different product. So let's look into that. Say that I want to perform that reaction. And so that's 2-chloropropane, and that's my Lewis acid. So think about this reagent as if you're generating the following electrophile. Not exactly that, but we're going to use that. Say now, if this is my electrophile, and you will do the attack, let's say over there. So nucleophilic attack by the pi electrons in the ring, then you will form the following. That's your product. So isopropyl benzene. Not a problem because here, this is a secondary carbocation, and a secondary carbocation is not going to rearrange to be a primary because it's less stable. But the other way around, it does happen. So let's look into the next example. In the next example, let's draw what it would be my electrophile if it is thinking as a, say, a free carbocation. If you have that and you form it, it would be this carbocation. And that's a terrible carbocation, is primary. But you can do here a 1,2 hydride shift. So carbon 1, carbon 2. So if you do a 1,2 hydride shift, then now your carbocation changes. Now the positive charge is here, and that is tertiary, which is much more stable. So when you generate something like that, your product is not going to be as if you attach it from here, but it's going to be, this is the electrophile. So let's see, in other words, your nucleophile is going to be attacking right there at that carbon. And therefore, your product now is going to be, you're attacking there, and it's that carbon that is going to be joined. That's path. And I'm going to edit that. So at the end, you're going to finish with this product. Okay, meaning that's where you're attaching. See, this carbon. Okay, so you would not able the product directly from that, which would be this. Let's see, new phenol. That is not formed. You do not form that because the carbocation will rearrange into a more stable product. So this is why some cases we don't use directly the Friedel-Craft alkylation, but we use the acylation. If we wanted to do that, we need to do another path. So if we wanted that product, we cannot do it directly with this. Instead, we need to plan an acylation. So I'm going to do now something. I'm going to modify my reagent and make it, instead of an alkyl chloride, I'm going to make it an acyl chloride. And same Lewis acid. If that's the case now, my product now, you're going to install the acyl group. Let's highlight it. So this is where you're going to be installing in your aromatic ring. So I'm gonna redraw it to make it a different color here. So that's your aromatic ring, and you will be installing this. Now this you can reduce, and if you do zinc diclemacine reduction, here HCl and heat, then you will reduce that, and now your product will be what we wanted at the beginning, which is reducing that group will give you not following now, no longer that exists. And this is what you will have. So notice the difference. So this path, the Friedel-Craft Alkylation, will give you a rearranged product. So to avoid that, we do the Friedel-Craft acylation followed by the Clemenson reduction. And we accomplish that. So things to consider again, look for if it is possible for a carbocation to rearrange, then we don't go directly with the alkylation. We do the acylation first.